Hey y'all, today we are going to switch things up a bit and we are going to start talking about triangles and specifically this theorem called the triangle inequality theorem. And so first a quick discussion about the anatomy of a triangle. When we want to name a triangle, we name a triangle using the triangle symbol and then the three letters that represent the vertices of the triangle. So here triangle ABC. And of course, every triangle has three sides and three angles. And so if we want to name those angles, we could just use the letter of the vertex. So this triangle has angle A, angle B, and angle C in it. And then there's three segments that make a triangle. And so we have segment AB, segment BC, and segment AC. And so as you already know, a triangle has three sides, three angles. But just a quick refresher to get you into the mode of talking about triangles. So the triangle inequality theorem tells us about what the side lengths can be in order for a triangle to exist. So you can't take just any three lengths and build a triangle out of them. And I can illustrate that a little bit better in class together. But the triangle inequality theorem says in order to make a triangle, in order for a triangle to exist, and I should fix my spelling here, then the sum, that means if you add the two smaller sides together, then that sum, when you add them together, must be bigger or greater than the third side length. So let's see that in practice. Let's see an example. I've got a few examples, a few sets of side lengths, and I want to know if I can build a triangle using sides with these side lengths. So let's look at this first one here, 8, 13, and 5. In order to build a triangle using side lengths 8, 13, and 5, I need to add the two smaller sides together, 8 and 5. I get 13. And then I compare it to that big side, which was also 13. And they're equal. The triangle inequality theorem says in order to make a triangle, the two smaller sides added needs to be bigger than the third side. So I'm unable to make a triangle with these three side lengths. Here I'm going to add 6 and 7, and again get 13. And I find out that 13, the sum of the two small sides, is bigger than the third side, 12. And so I would be able to make a triangle using those three lengths. This one, it's okay to have a triangle that has two sides the same. That's just called an isosceles triangle. So I add those two small sides, I get 8. 8 is smaller than the third side 10. So in this case, we can't build that triangle anyways because the two smaller sides added is smaller than the third side. So I've got a few here I want you to try, just like we did on the last three. Use those three as an example, and I want you to try these three and figure out whether or not I could build these triangles. So pause here, try these three, and then press play for the answers. So it turns out I could build this first one because the two smaller sides added is bigger than 12, the biggest side. Here I can't build. The one in the middle I can't make because the two smaller sides added is equal to the third side, and that doesn't follow the rule. And again, I could build the last one. The two smaller sides added together is bigger than the third side, and so I could make a triangle. So we're going to go over this idea again in class. If you have any questions, please ask, and I'll try to do a visual for you to show you that we can't just make a triangle out of any three side lengths. We have to follow the rule. So try these three problems. Go over the answers in class, just like those 6 we did together on the lesson, and determine if each of these three could make